set up impulse. I think that this also we needed, no? Means all forces can set up impulse or only some specific forces. How to generalize it? And now this is a general discussion I'm making, so this will really help you to identify in numericals whether impulse will be set up or not. Initially, they are a test, the blocks A and B. So like this is A, this is B, they are a test, and there's a particle moving with a speed u. It will collide inelastically. Then initially some tension is there, no? How much of tension? T naught. And what is T naught? Equal to mg. Now collision occurs, inelastic collision occurs, and it'll get stuck to it. We'll take like this. So the combined mass will have a velocity v. And what will happen to just after collision? The string, what happen, will be loose. Just after impact, the string will become loose. Any impulse in the string? No, will not set up. The tension will happen from T naught equal to mg has become 0 because this was the test. This was the test, and the combined block, what will happen? Will start moving up, no? The string will become slack. Tell me where is the question of impulse now? Nothing, no? So therefore, if a force from non-zero suddenly becomes 0, then no impulse is set up. So will there be an impulse due to normal contact? Yes, it will be there. I'm talking about the impulse in the string. The tension from non-zero suddenly becomes 0. No impulse. You should not put any impulse here. No question of discussion, no? Because string slack means no question of there any tension. So if there is no force, no question of impulse. Is it justified? The part of graph which I wanted to take here. This will be a very important idea for you. Then so what will happen here? What will happen? This will start moving, ascending up. This will start descending up. Like a body projected vertically up, this will be freely falling body. And what happened to string? As long as they're falling freely, this falling freely, and this is vertically projected, string will be slack only. So there's a first condition. So let's introduce spring now. And I'll bring the spring. No, you take it. This is B. Initially, what is the state of spring? Elongated, and that same spring force will act, and that is what the tension. Kx naught equal to mg and T equal to Kx naught. So therefore, T equal to mg. So this particular ball will collide. Inelastic collision, E equal to 0, you write it. Tell me here what will happen to the impulse by the spring now. So what should happen to the spring force? What will happen to the string? So this is the string. Already in laws of motion, I discussed few numericals, if you can recollect. So this will become slack, no? This will be slack. And they will have combined velocity v. The string will become slack. Then what happened to spring? Suddenly what happened? The energy in the spring will vanish. So where do it will go? Who should take that one? Block M, block B. No, block B cannot take that one. If block B is taking means some impulse is acting that one. So that should be taken by the string again. This I'll write slack here. No spring force. Now this will start falling freely, this will ascend. We have discussed some problems here, that one. So x naught will become 0. So what is the conclusion? Now sudden change in spring force not possible, but here the situation is like this. The one end of spring is connected to string. So definitely here sudden change in spring force possible here. I think we should not make a firm conclusion. Sudden change in spring force not possible in some situation. But here what happened? The spring force will change. And what happened to that elastic potential will be taken by the string. So here also there will be heat generated. The next situation, this will be much easier for you. And the particle will come and collide. Initially there is a elongation in the spring. So when any impulse is set up by the spring, because the one end of the spring is connected to the string. Now, I think I discussed this problem in laws of motion. From Pathfinder I picked up, I discussed it. This end of the same situation, this end of the one end of the spring is connected to the block, the other end is connected to the string here. So the string will become slack. So the energy in the spring will vanish. We discussed even numerical also. Strings cut. There we have discussed this. Okay, the particle will come and collide. Okay, now tell me, like at least here there should be impulse at least. Collision will occur. So during collision, the impulse due to normal contact will act here, and the impulse due to normal contact will act here. No? And because of that, both will have common velocity. Tell me what will happen to spring force. Will it change here? No, it will remain as it is. Because what we are discussing, the moment collision occurs, we are discussing, no? When the spring deformation will occur. Now, because of velocity, as it starts moving, then the deformation occurs. So any impulse here, no impulse by the spring. I think this will be no impulse by the spring. That I think sudden change in spring force not possible. I think that's based on the situation. No, here not possible. Here it's possible. No, the spring energy itself will vanish. Spring force vanishes. So so I think you have to be very careful about the conditions available, and you can't generalize. This is one situation, this is one situation, and there's another situation. So don't go for any generalization. So now spring force, can it set up impulse? I don't think so. We have any numerical. Sudden change in spring force, here it vanishes. So, but sudden increase in spring force not possible. But sudden decrease in spring force possible. Sudden increase in spring force not possible. You can also put block. Means like I'll take another system. Let me give one more last year. Maybe, sir, in this case, let's see. I'll drop a ball. So the ball is moving with a velocity u. And it will get stuck to it. So what is the spring force? Kx naught will balance mg. Now in this case, there'll be normal contact, impulse due to normal contact, and this Jn. This, what it will do, will impart velocity v like this. But look at the spring. When it will start undergo deformation because of velocity, when this combined block start moving, the spring will undergo deformation. No? So the spring force will retain its, the spring will retain its deformation. So any impulse now? So no impulse. Okay, these are the
Sir?
some.
Sir?
Yes, I'm hearing, ma. Yeah.
Sir, in this example, sir, here spring force is getting managed, right, sir, in the first example.
Yeah, okay.
But there won't be any impulse set up by the spring, no, sir?
Yes, yeah, that's all.
Okay, sir.
That's why I see, like, I gave graph. It's not like something story I'm not telling here. I've given enough proof like this. So this particular graph, so impulse is set up. Here I can put it now. Now I can conclude. Impulse is set up. Delta T1. During delta T1, impulse is set up. Now, during delta T2, impulse is set up. During delta T3 and delta T4, no impulse is set up. Impulse is not set up, you're right. Impulse is. See, like, see, this is not the graph is not a concept. The situations are that different. Like this, when we go and analyze the different situations, no, we do come across, okay, this is what practically happens. Then I'm summarizing everything in the form of graph. So I think this will be now very convenient for you. Sir, is it for spring force or for any force? For any force it is. That's why I didn't write spring force here. This is a generalization. Getting idea? So I think you have to be very careful about now the forces when impulse is set up, when impulse is not set up. You should have a clarity. Before entering into this topic, we must have a background